Hey everyone, welcome to Deep Tips. So today we are back with another stream on trigonometry. So far I have done 3 streams on trigonometry and this is my fourth live stream which is based on complementary angles. But children, I have discussed complementary angles in yesterday's video also when I explained you the trigonometry table. Trigonometry ratio table is something that is very important. So I am waiting for everyone to join me in so that I can start my class. And thank you Vikhyati for subscribing and tuning in. So children, I am waiting for you all. If you have joined the stream, write in the chat hi, hello something so that I get to know who all are there. So we'll start our class in few minutes. So complementary angles are something that you have learnt in your previous grades also, right? So complementary means when sum of two angles is 90 degree. And there are supplementary angles also, which means sum of two angles is 180 degree. But today we are going to learn the importance of complementary angles in trigonometry and why they are equals. First, this why is very important in mathematics because I don't support the rote learning. Questioning and reasoning is the main foundation of math. If you don't question, if you don't reason a formula, then you are doing rote learning. So it's important to find out that why, answer to that why question so that you understand the concept. Okay, so yeah. So children, so far in previous 3 streams, those who are tuning in for the first time, just for your knowledge, I'll tell you, in the previous 3 streams, we have done the introduction to trigonometry, relationship between different sides and trigonometric ratios, and then in second stream, we learned about the different angles that are important in grade 10 and which you learn for your board exam. So we learned the proofs of those trigonometric ratios, that how do we get the values for theta 45 degree, 0, 60, 90 and 30 degree. In third stream we did questions on trigonometric angles, and now today we are going to start with complementary angles. So I think you people have joined in, so I'm going to start my class. Okay, so let's begin. Yeah. So if you look at my screen, I have drawn a right angle triangle which is right angled at B. So we know that the sum of 3 angles of a triangle is 180 degree, correct? So if I say angle A plus angle B plus angle C, their sum is equals to 180 degree using angle sum property. But one of my angle, that is angle B, is already 90 degree because I have drawn a right angle triangle. So that means remaining 2 angles, angle A and C, they should be complementary angles, correct? Their sum should be equal to 90 degree. So if I take my angle A as theta, my angle C will be 90 minus theta. Something like this I discussed with you yesterday, that when we take angle A 30 degree, angle C is going to be 90 minus 30, that is 60, right? And how complementary angles are equal to each other we are going to learn today. So first we will do the proofs, and then in this stream we are going to do few questions that came in board exams. So this is a very important video for CBSE students as well as ICSE grade 9 students, because in ICSE this is in grade 9, but for grade 10 also it is important because sometimes you have proof from complementary angles also. So children, now I have angle A as theta and angle C is 90 minus theta, and you remember in one of the video we learned how to identify the sides of the triangle, and the easiest one to locate is hypotenuse, because hypotenuse is always the same and it is opposite to the right angle. So opposite to right angle is AC, so this is my hypotenuse, that stays the same. It doesn't change with the angle. So when I am taking angle A or angle theta, then AB is my base and BC is my perpendicular. And when I am taking angle C, that is 90 minus theta, then BC is my base and AB is the perpendicular. So this is how we identify the sides of the triangle, right? So now let's compare sine theta. Let's write sine theta first. So sine theta is perpendicular upon hypotenuse. So I just recall you in every video our famous Pandit ji formula, Pandit Badri Prasad Hari Hari Bole Sona Chandi Tole, right? Pandit Badri Prasad Hari Hari Bole Sona Chandi Tole. So here P means perpendicular, B means base, H means hypotenuse, S is sine, C for cosine and T for tangent. Okay, so sine is perpendicular upon hypotenuse. So theta, my perpendicular is BC and hypotenuse is AC. Correct? Now if I have to write cos theta is base upon hypotenuse. So my base is AB and my hypotenuse is AC. Correct? So these are the relations of the sides that we have already learned. Okay, now I have tan theta. Tan theta is perpendicular upon base. So perpendicular is BC and base is AB. Correct? So if I write now cosecant theta, that is just reciprocal of sine theta. So I can write directly AC by BC. And my secant theta is reciprocal of cos theta. So AC by AB. Okay. So these are the 5 trigonometric ratios. What is missing? Cot theta. So cot theta is something AB upon BC because it is the reciprocal of tan theta. So these are clear to everyone that how to write trigonometric ratios for theta. Now let's write for the complementary angle. Complementary of theta is 90 minus theta. Correct? So now sine 90 minus theta is the complementary. 90 minus theta is the complementary of theta. So if I am taking this 90 minus theta, let's change the color. Okay, so if I'm taking 90 minus theta, my base becomes BC and my perpendicular is AB. So I know sine theta is perpendicular upon hypotenuse. So AB upon AC. So let's write here AB upon AC. Now can you observe something, children, that sine 90 minus theta is same as cos theta. So now can you relate the name cos theta? Complementary of sine, right? So complementary of sine cos theta is equals to sine 90 minus theta. So whenever you have sine 90 minus theta, its value is going to be equal to cos theta. I mean to say, if I am writing for cos 60, we know that cos 60 is 1 by 2 and sine 90 minus 60 gives me sine 30, that is also 1 by 2. So this is how complementary angles are related to each other in trigonometry. So now when I am taking cos 90 minus theta, so now you can tell me what is 90 minus theta cosine. Okay, so this is base upon hypotenuse. So here my base is BC and hypotenuse is AC. So you can very well see that cos 90 minus theta is same as sine theta. So this is their relationship that we just remember, that sine 90 minus theta is equals to cos theta. So here in this video we are learning why sine 90 minus theta is equals to cos theta, because they are complementary to each other. That's why this topic is complementary angles, and we are learning the relationship between complementary angles. Okay, so when I write here tan 90 minus theta. So tan 90 minus theta is equals to AB upon BC, and you can see that it is equals to cot theta, right? So tan 90 minus theta is equals to cot theta. Okay, now next is cosecant 90 minus theta. So cosecant 90 minus theta will be reciprocal of sine 90 minus theta. Okay, so cosecant 90 minus theta will be equals to AC upon AB, and you can see that cosecant 90 minus theta is same as secant theta, right? Now we have secant 90 minus theta. Secant 90 minus theta will be the reciprocal of cos 90 minus theta. So I have cos 90 minus theta as BC by AC. So secant 90 minus theta is AC by BC, which is same as cosecant theta, right? And the last one, that is cot 90 minus theta, which is the reciprocal of tan 90 minus theta. So this is equals to BC by AB, and which is same as tan theta. So we have derived the relationship of all the complementary angles. So now I can write my results because I have proved them here. If you have any doubt regarding complementary angles, you can type your question in the chat. I will answer you. Okay, so now I can write here that sine. Okay, let's change the color to write the final results. Okay, so yeah, so I can write here that sine 90 minus theta is equals to cos theta, correct? And cos 90 minus theta is equals to sine theta. We are going to use these results in our sums. That's why I'm writing it here. Okay, now I'm done with sine theta equals to cos 90 minus theta, and I'm done with cos theta equals to sine 90 minus theta, correct? Now let's look at tan theta. So tan 90 minus theta is equals to cot theta, and cosecant 90 minus theta, here it is, cosecant 90 minus theta is same as secant theta. Okay, and then we have secant 90 minus theta. Secant 90 minus theta is this, and which is same as cosecant theta. So this is equals to cosecant theta. And now last one is cot 90 minus theta. So here is my cot 90 minus theta, and this is BC by AB, and you can see that it is same as tan theta. So here it is, cot 90 minus theta is equals to tan theta. So children, we have just derived the complementary angles, and we have written the relationships also, which are very important, and you use these relationships directly in the board exam. Okay, so now I'm going to start with the questions based on complementary angles. In this video we are going to do 6 questions. All 6 are different and they are chosen from the previous board exams. So we will be doing those questions, and I hope you are clear with this concept. If you have any doubt, you can type in the chat. I will be glad to answer your queries. So I'll be back in few seconds. Okay, so if secant A is 15 by 7 and A plus B is 90 degree. So look at the question. If secant A is 15 by 7 and A plus B is equals to 90 degree, find cosecant B. So this is a very simple question and one marker. This question doesn't carry much marks, but still this is a scoring question. You can just look at the question and answer within a second. So this question can be asked in CBSE board exam for 1 mark. I will gradually move to 4 marks questions. So first we'll work on the foundation, how to use these relationships, and then we'll solve complicated questions. Okay. So now if you look at this question, it's clearly mentioned that secant A is 15 by 7 and A plus B equals to 90 degree. That means A and B are complementary angles. So if secant A is 15 by 7, what is cosecant B? Okay, so I know that B can be written as 90 minus A, right? Or A can be written as 90 minus B, correct? So in this question I have secant A given, so it's convenient for me to change this A to 90 minus B. I can rewrite this expression secant A as secant 90 minus B equals to 15 by 7. Now if you look at the relationships, I have this relationship which says secant 90 minus theta is equals to cosecant theta. Okay, so here I have secant 90 minus B, so theta is B here. So I can use this relationship secant 90 minus theta equals to cosecant theta. So now what will I write? Cosecant theta. So cosecant theta means B here. So cosecant B is equals to 15 by 7. So just in 2 steps I got my answer. So answer is cosecant B equals to 15 by 7. So this is how you do this question. This is kind of mental maths of trigonometry, right? So you can just do this question by looking at the question carefully and you can solve it orally. Okay, so this is how we do this. Now let's move on to second question. And the second question says, without using trigonometric table, solve the question. Okay, so question is 11 sine 70 degree upon 7 cos 20 degree. Okay, 11 sine 70 degree upon 7 cos 20 degree minus 4 by 7 cos 53 cosecant 37 upon tan 15 tan 35 tan 55 degrees I am putting here and tan 75 degrees. Okay, so we have to evaluate this question. We have to find the answer for this question without using trigonometric table. You cannot use the table and write the values for sine 70 cos 20 or 53 37. You have to calculate, you have to evaluate, but without using the table. So this is the beauty of this question. So here we will use complementary angles that we have learned. So complementary angles means sum of two angles is 90 degree. So the trick to solve these questions is first identify the pairs which adds up to 90 degree. Okay, so when I look at the expression, sine 70 and cos 20 is written here, and we know that complementary of 70 degree is 20 only, because 90 minus 70 gives me 20. So can I write this sine 70 as it is? And let's do one change here. So cos 20 can be written as 90 minus 70, because 90 minus 70 is 20 only, right? So it's another way of writing. So I can just write 20 as 90 minus 70. So if I look at this angle, cos 20 and cos 90 minus 70, it is the same thing, only way of writing is different, correct? So this is how, okay, just a minute. Yeah, I'll just erase this. Okay, So now if you look here, yeah, first part is done. Now look at the second part, which has so many angles here, and I can clearly see that my 53 and 37, they add up to 90 degree, right? I know that 53 plus 37 is equals to 90 degree, correct? So I can rewrite any of the angle, that's my wish. So I would like to rewrite, because cos 53 I can write as it is. I can change cosecant 37. I'll write it as 90 minus 53, which I can always do because I know that 90 minus 53 gives me 37, correct? So I have just rewrite 37 as 90 minus 53 in another way. Now let's look in the denominator where there are four angles, but four angles we need to identify first which two add up to 90 degree. So I know that 15 and 35 does not add up to 90, so I'll try another combination. 15 and 55, if I add them, they also don't add up to 90 degree. So which two combinations I can make? I can choose tan 15 and tan 75 together, and tan 35 and tan 55 together, because 35 plus 55 gives me 90 and 15 plus 75 gives me 90. So these two angles, 15 degree and 75 degree, they are complementary angles. They are a pair of complementary angles. If I just look at 15 degree and 75 degree, if you add them you get 90 degree. Same way, if you add 35 degree and 55 degree, you get 90 degree, right? So how do we solve this? So here, when I know 15 and 75, they both are complementary. Either I can rewrite 15 or 75, up to you. You can just do this, and in the next step I'll tell you why we did the rewriting thing, why we did that. Okay, so now first let's do that. So I am just writing small angles as it is 10, 15 and 35. So I know that tan 55 can be written as 90 minus 35, because 90 minus 35 gives me 55 degree. So I can write it as 90 minus 35. Now this 75 can be written as tan 90 minus 15. Yes, this can be written as 90 minus 15. So now my rewriting part is done. This is the very important step, the second step. If you are clear with this, please send a thumbs up in the chat. If you have any doubt, you can post a query. Okay, so understanding this rewriting part is very important. So first, now rewriting thing is done. Now comes our relationships, because we know that when I write a trigonometric ratio in the form of 90 minus theta, when I write sine 90 minus theta, I can directly write that it is equals to cos theta, because we have just proved it, correct? So here I have 11 sine 70 upon 7. Now see here, cos 90 minus theta, it can be written as sine theta. So I will write it as now sine 70, because this is my theta here. My theta is 70. So cos 90 minus theta can be written as sine theta. That's why I have written here sine 70. Now next one, 4 by 7 as it is. Okay. Then cos 53, and then I have cosecant 90 minus theta, right? This is my theta here, 90 minus theta. So cosecant 90 minus theta is equals to secant theta. So I can write here into secant 53. Okay. Now next step in the denominator. So this is my tan 15 as it is, tan 35, I am putting dots. Dots mean here multiplication. Then I have tan 90 minus 35, means tan 90 minus theta. My theta is 35. So tan 90 minus theta is cot theta. So I can write here cot 35. Now next is tan 90 minus 15. So this can be written as cot 15, correct? So now you must be clear that why I did that rewriting part in second step, where I changed the angles to their complementary angles, and then in third step I use the relationships that we learned in the beginning of the video. Okay, so then we use that cos 90 minus theta is equals to sine theta, and cosecant 90 minus theta equals to secant theta. So we made use like of all these things. Now I can clearly see that sine 70 and sine 70 can be cancelled. So I am left with 11 by 7 here. Okay, minus 4 by 7. Now cos 53, and I know that secant can be written as 1 by cos. Why? Because while doing the trigonometric ratios, we learned that the reciprocal of cos gives us secant. So that's why secant 53 can be written as 1 by cos 53. Okay, and what is the reciprocal of tan? That is cot. So here these two as it is, and this cot 35 can be written as 1 by tan 35, and this cot 15 can be written as 1 by tan 15. Now if you see here, these can get cancel, cancel and cancel. Okay, so now we have 11 by 7 minus 4 by 7. So if you solve this, 7 is your denominator after taking LCM. 11 minus 4 is also 7. So 7 by 7 is equals to 1. So 1 is the answer to such a big question. I hope you are clear with the concept, how to make use of complementary angles and how to rewrite the angles and then use the given formula. So I'll be back in a second. Okay children, now third question is based on a proving question. Okay, so I know some students find proof questions quite difficult in geometry, but I tell you that proving the questions or proving trigonometric identities is the simplest one. And my next video tomorrow is based on trigonometry identities, where we are going to do lots of proving questions. Okay, so now this question is based on complementary angles proof. So question says, prove that cos of 90 minus a into sine of 90 minus a upon tan of 90 minus a is equals to sine square a. So this is what we have to prove. This is my third question. Okay, so let's take left hand side. I'm not going to write it again. We are taking left hand side, and cos of 90 minus a. A is a theta. We can write theta also. We can write a, b, c, whatever you want to. But in the question, it's given a, so you have to take it as a. So cos 90 minus theta is equals to what? You can write your answer in the chat. So cos 90 minus a is equals to sine a. So I can write here sine a. Okay, and what is sine 90 minus a? Sine 90 minus a means sine 90 minus theta, that is equals to cos theta. So I can write here cos a. Now tan 90 minus a can be written as cot a, but in the right hand side I have sine square a. So how do I get sine square a? Okay, so now let's simplify this. I know sine a and cos a cannot be further simplified, but I can simplify cot a as cos a upon sine a, right? Because cot theta is equals to cos theta upon sine theta. So here cos a get cancelled, and then this sine a can go up. So sine a into sine a gives me sine square a, which is your RHS. So we can say left hand side is equals to right hand side. So this was such a simple proof which can come for 2 marks. Okay, so in proofs you just go with the flow. first look carefully what is given on left hand side and what you have to prove on right hand side. So just try to bring the things that are on right hand side in left hand side, like by converting it or by using the formulas or identities whatever you have, and try to change it to the RHS. So we will do many proofs tomorrow in trigonometric identities. Okay, so yeah, now we have to do our fourth question, which is a proving question again, and this question sometimes comes in competitive exams also. Okay, so it says that prove tan 10 degree into tan 75 degree into tan 15 degree into tan 80 degree is equals to 1. Okay, so here again you have to prove that in LHS you have tan 10 into tan 75 into tan 15 into tan 80. If you do the product of all these four trigonometric ratios, then trigonometric uh, okay angles, then you get RHS as 1. Okay, so tan 10 75 15 and 80 you have all in tans. So I told you, when you have these kind of angles, first make the pairs of complementary angles. So I can clearly see that if I add 10 and 80 I get 90 degree, and if I add 75 and 15 I get 90 degree, right? So I can start rewriting my thing. So tan 10 can be written as 90 minus 80, right? And tan 75 can be written as 90 minus 15. So let us write this tan 15 and tan 80 as it is. I am taking LHS, so I'll write it here. So now I know this become my tan 90 minus theta. 90 minus 80, I can write 90 minus theta, where theta is 80. So tan 90 minus theta is cot 80 degree, correct? And tan 90 minus 15 becomes cot 15 degree. And this tan 15 and tan 80, they stay the same. Now I know that cot 80 can be written as 1 by tan. So I'll write here 1 by tan 80 into 1 by tan 15 to tan 15 as it is, and into tan 80. Okay, so if you look here, all these get cancelled. So 1 into 1 is equals to 1, and my LHS is equals to RHS. So this is how we make use of complementary angles in proving these types of questions. I hope you are clear with this. I have two more questions to solve, and they are 4 markers. So far we have done the questions which came for 1 mark and 2 mark in board exam, but I have 2 more questions that came for 4 marks. So I have my question number 5, which has secant 39 upon cosecant 51, okay, plus 2 by root 3 into tan 17 into tan 38 tan 60 tan 52 and tan 73. So this is the question. It looks a huge question, but in actually when you start solving it using complementary angles, it is pretty simple. So again, the mantra to solve these questions is first identify the pairs. So here I can clearly see that 39 plus 51 gives me 90. So 39 and 51 are complementary angles. Now here when I look here, I have 1, 2, 3, 4, 5 different angles, but I know the value for this particular angle tan 60. I know that this is equals to root 3. So I am left with 17, 38, 52 and 73. So 17 plus 73 gives me 90 degree. 38 plus 52 also gives me 90 degree, right? So I know my pairs. So let's start the rewriting thing. So I can write secant 39 as 90 minus 51 because I know 90 minus 51 gives me 39, and here cosecant 51 will stay as it is. Now when I rewrite here, 2 by root 3 stays the same. Let's write tan 17 and tan 38 as it is, okay, and tan 60 is root 3, so I am writing the value here. Tan 52 can be written as tan of 90 minus, we know that 38 plus 52 gives us 90, so I can write here 90 minus 38. Yeah, just a minute. Okay, and this tan 73 can be written as tan of 90 minus 70. Okay, so now this is secant 90 minus theta, which can be written as cosecant 51, and this is also cosecant 51, right? Now here root 3's can get cancelled, so I am just left with 2 here, into tan 17 into tan 38 into cot 38. You know why I am writing cot 38? We have done this in the previous questions also, that tan 90 minus theta can be written as cot theta, and same way tan 90 minus 17 can be written as cot 17, and this get cancelled. So here it is 1 plus 2 tan 17 into tan 38 into 1 by tan 38 into 1 by tan 17, because I know that cot 38 can be written as 1 by tan 38, so they get cancel here. 2 into 1 gives me 2, 1 plus 2, which implies my answer is 3. So 3 is the answer for this question. This question sometimes comes for 4 marks with a little more extension of the identities. Like there may be one more part by adding something to this question, and then this question comes for 4 marks. But if it comes like this can come for 3 marks. Okay. So now I have one more question to solve, which is a proof question, and it is a 4 marks question. Okay. So it says if a plus b is equals to 90 degree, okay, then prove that, now prove is in square root, so it's under the root, so tan a tan b plus tan a cot b upon sine a secant b, okay, minus sine square b upon cos square a. This is the question, and we have to prove that it is equals to tan of a, tan a. So this is a question, that is a proving question. So when they are saying a plus b is 90 degree, we can write that, okay, then b is equals to 90 minus a, or a is equals to 90 minus b. I need any one of them, so I have taken b as 90 minus a. Why I am doing that? Because I have tan a in the right hand side. I want angle a, so that means, now here the trick is, the tip for this question is that when you are solving such kind of question, first look at the right hand side, that what angle they are asking for. Are they asking for b or a? If they are asking for a, then change b to a. Okay, if they are asking for b, then convert angle a in terms of b by substituting. So now here my RHS is tan a, that's why I am changing the b to 90 minus a. Okay, so now let's solve it further. I will write in my root, that is my left hand side, tan a will stay the same, but tan b can be written as 90 minus a plus tan a cot of 90 minus a, and then in the denominator I have sine a and secant 90 minus a. Okay, I hope this is clear to everyone that how we are doing this. In place of b I have substituted 90 minus a. Now minus sine square 90 minus a upon cot square a. So this is basically a very simple question. Only thing is children get scared looking at the square root. So if you know the method, if you know the trick that how to solve this, how to go about this question, you will just finish it in 2 to 3 minutes and 4 marks are all yours. Okay, so now if you look here, tan a stays the same and we know that tan 90 minus a is equals to cot a, correct? And then tan a as it is, and we know that cot 90 minus a is equals to tan a upon sine a, and secant 90 minus a is equals to cosecant a, and minus this sine square 90 minus theta is equals to cos square theta. So I'll write here cos square a upon cos square a. Okay, so this is how we solve till here. Now this get cancelled. Okay, and we know that this tan a and cot a can get cancelled, but for your understanding I am simplifying it further, that cot a can be written as 1 by tan a plus tan a into tan a becomes tan square a upon this sine a into cosecant a can be written as 1 upon sine a, right? And this is here minus 1. So these tan a get cancelled, this sine a also get cancelled. So what do I have here? I have 1 plus tan square a minus 1, right? So this 1 and 1 get cancelled, and in the bracket I have only tan square a. So if I want to take it out, I get tan a, which is my right hand side. So I can write LHS equals to RHS. So this is how we do the proof questions. I hope you are clear with the concept. Today I didn't have much questions, so I feel children are pretty much clear with the concept and they understood how to do this. But still, if you have any query or you want to ask me something, you can type in the chat. I would be happy to answer your queries. Okay, so we are done with today's session, which was all about complementary angles and the practice questions based on complementary angles. But tomorrow we are going to do a very important topic, that is trigonometric identities. And children, both ICSE and CBSE students have trigonometric identities in their syllabus, and they do get a question from that topic in board exam. So remaining 3 streams I will be focusing on trigonometric identities and then height and distances. I know you all are waiting for heights and distances because that is something children find difficult, but I'll make sure that you understand it easily. Okay, so we are done with today's class. Thank you for tuning in. Keep watching Deep Tips. Please like my channel, subscribe it and share it with your friends. Okay, thank you so much. Good night.